I must be the only show in town at this moment, right? Or you all missed your trains. So my name's Keesup Choe. I'm the CEO of PredictX, and we're a SaaS company. We help large enterprises manage spend and CO2. One of our modules look for things like employee fraud, for instance. Okay, so I'm going to talk about business intelligence and predictive analytics, kind of what's different about it, where things are going, and kind of how we do, how we actually serve our customers in this way, and how we architect our products. All right. So AI is ubiquitous. We all know that. You have this. Some of you have it. Traffic management, if you're from China, they know who you are. You should have stopped. Automatic photo optimization on your phones, so you don't even know this is happening, right? And we have various assistants to help us with our daily lives. So AI, well, obviously, TikTok, it wouldn't exist without AI. And of course, e-commerce is kind of where it all started, the application of AI. Not just yet, but eventually, right? So AI is now ubiquitous for the consumer as a user. But what about for the enterprise? So as an example, how many of you have asked the question, hey Siri, hey Alexa, hey G word, because if I say that, lots of Androids are going to go off, right? And ask the question, how many have done that in your own private life as a consumer, as a user of your phone? Yeah? Okay. So, but the G assistant is incredibly, at least for me, very responsive, right? And sometimes she asks me, can I help you, even if I don't say that word. Has that ever happened to you? Anyway, so how many of you have used these same assistants or other assistants like this at work? Hey, G, which SKU is going to be the most responsive to my next marketing campaign? No? Okay, so it's different in the enterprise, isn't it? So let's go back and talk about BI before we get to AI. Okay, so Cognos is probably the first business intelligence system that was commercialized. Any guesses for when they first went to market? So this would be one of those quiz shows. Which decade? Is it the 2010s? Any hands? Aughts? 1990s? 1980s? Ooh. 1970s? 1960s? 1969. It's been around for a while, and it's still one of the biggest BI vendors out there, owned by IBM. Oracle and Hyperion. This is just some random examples. There's hundreds, really. 1981. Business Objects, owned by SAP, 1990. Interesting funny fact, they announced in 2020 that they're ending support for Flash. In case, you're still running your business objects on Flash, no soup for you, okay? Even probably the best known is 2003. So this is before the cloud. This is before containerization. This is before everything you guys are either using or learning how to use or deploying. So this is a pretty mature technology, and most big enterprises have adopted this to run stuff. Okay? So it's 53 years old. So my contention is that the analyze and fix of this BI tools, which is retrospective and report-based, where you view, drill, filter, and you see something, and maybe you find an issue, and then you go try to fix it, that is going to be, or has been replaced with the AI world. You predict and you prevent, you prescribe without analyzing and fixing. So if it's that compelling, and we're all using AI, right? We know that. Why aren't you? Why is it different in the enterprise? So, according to Forbes, as far as true machine learning data science projects in production, 22% of surveyed enterprises said they have one in production, 9% multiple, first one under development, no plans, next year, next 2 years. So it's not as ubiquitous as you would think, given how compelling it is to move from analyze and fix to predict and prevent. Yet it is now easier than ever to deploy these data science projects. Okay, is it because there's no compelling use cases in the enterprise? Maybe. I'll come back to that one. All right. No shortage of use cases, right? Which SKUs are going to be the most popular, et cetera, et cetera. Can I predict which equipment I'll need? Which content will increase engagement? What's the seasonally adjusted sales forecast for these SKUs? I mean, endless amount of questions you could be answering from a predictive perspective. And, going backwards, it is easier than ever to write data science models to answer these questions. So, my daughter in middle school learned how to use Jupyter and how to use pandas to organize the data and random forest models from scikit-learn. Kids can do this. Kids can do this, on one hand, now. Massive use cases from the enterprise. 22% says they have one project in production. Something's not quite right. Okay, so the enterprise has various departments with these use cases, and what normally happens, unless your company is a company that's producing AI, like self-adjusting phones and all the other stuff we talked about for the consumer, but if you're an enterprise and you're selling whatever, your business isn't to produce AI, then you probably have these use cases, and you have a data scientist or a data science team who's not necessarily in middle school, but maybe just looks like it. So that's usually what happens. Business unit, the business says, I need some answers. They've hired a data science team. Not cheap, right? And they'll answer your questions for you with Jupyter, with Keras, with all the tools now that's so easy to incorporate. So what's wrong with that? Well, there's no self-service AI, really, right? If you think of the BI world, what really changed the game was self-service BI, where the end user can kind of click around and figure out answers. No such thing really exists. Other than if you're a user who happens to know how to use Jupyter notebooks and so on and so forth, which causes a whole other set of problems. Okay. Data science at enterprise tend to be a series of one-off projects and prototypes. So what if you need it every day? What's the problem, right? As Elon Musk said, Prototypes are easy. Production is hard. It's the same for cars. And it's the same for machine learning. Why is that? Okay. There's a data wrangling problem. So in BI, you have an ETL problem. You think that's a problem. It's not the same thing. So poor data quality, say a missing value, or some units in millimeters, whereas the rest of it's in centimeters, and things like that, which in the BI world throw your sums off by a little bit. Your means are slightly off, but you can still use it. Kind of a big problem for AI when you're training it. Data labeling. You want to use auto labeling, but it takes a while to get there. And depending on some of the questions you want to answer, you may not have enough edge case data to properly train the model. So it would be nice to have a platform to automatically wrangle this data at scale. Data science ordinarily doesn't follow development best practices. So this enterprise will have an established IT team with a CTO, and they'll have a software development lifecycle process in place. Good for you. And it works, everything's logged, it's in, the whole thing with the QA mechanism. This makes, yes, it happens all the time. And not consistent with modern architectures, because you're running inline code in Jupyter. Where's my object? Where's my endpoints? How do I deploy them in a scalable manner? How does that fit into my microservices? Trained data science models often are not reusable, easily supportable. So if you think about supportability, every data scientist has models. Every model is linking many libraries. Each of those libraries are linking other libraries. On average, every one of those libraries are being upgraded every 3 months. Some of them with urgent fixes for vulnerabilities, right? Is that being up to date? Okay. There's no self-service, right? So this is our architecture. This is kind of how we try to handle the problem. I'm not going to go through all of this stuff with you. I'm sure a lot of you have similar looking things. But just to point out a couple things, we have repositories of trained machine learning models that is checked in and out. They're deployed through container orchestration. Each one of them are controlled by secrets that depend on the client and the user to make sure that user and the client is authorized to spin up that model and get the answers they need. It's deployed through microservices, and all the endpoints are then coordinated, API managed. So this is kind of how we do it. And two things I'll pull out of this of what our clients see. So because obviously our clients don't see this. Severe endpoints, okay. Pilot is our automated data wrangling. So it's kind of like ETL. ETL is a deterministic way to transform data. What you really need is a probabilistic system that takes care of things like, basically, can you join multiple data sets that have no common identifier? If the answer is yes, then you have a probabilistic data wrangling system. Okay? And the Hollywood is our data science application. It's deployment system. It's basically giving our users a self-service AI app. Okay, so that's what we do. And just to give a little shout out, our stuff is all self-homegrown plus open source stuff. The only commercial technology we use and leverage on is stuff by Actian. which helped us, a lot of different tooling that we use from Actian to help to deploy what we do. Okay. So in summary, if you can, you want to, all the good learning from school and 70 years of good development practice, you want to bring your data science development within an SDLC process. Auto data wrangling would be great if you can do this. Yeah, training data feedback. Okay, which means the model isn't the algorithm. That's not the model. The model is now generic. Everybody has access to the same model. It's the trained model that's your moat, right? That comes from managing your data. So you want to have auto data wrangling that does auto feature extraction, that gives you a trained model that's getting better and better and better. That's the model, not the algorithm. Bulletproof production process to turn prototype into production. So, yeah. You don't want to run these things inline in Jupyter. Yeah, and if you can give your end users access to these models so they can answer their own questions, then we're getting close to what took 53 years for BI to achieve. Well, that's it. Thank you. So we have time for a few questions, if you have any. First of all, does anything that I've said make any sense to any of you? So if not, then I have to change my talk for the next one. No? Excellent, okay. Any of this familiar? Yeah, how things work? Okay. No questions, and thank you so much. Oh, one question over there, sorry, yeah.
So it may or may not be applicable, but I was just wondering how you deal with the explainability problem. If someone comes to you and says, how did you arrive at that decision? What do you do about that?
Yeah, I think you have to be upfront with them. So if you say, this is a supervised model, it could be some sort of gradient descent or whatever it is, then you say, then it's easy. Then the feature extraction gives you the parameters. It gives you the weights. So you can say, you wanted to predict this. I've used this model. And it tells us that the biggest predictor is age, whatever, and you can see it. Now, for, say, computer vision, that doesn't work. You have an unsupervised model, some sort of neural network and whatever. Then you have to say, I really don't know. This is an unsupervised model. There is no actual literal features, and it gives you the answers. Only thing I can tell you is I can measure, you can give them all the error scores and the accuracy scores, all of that stuff. Of course, they won't really understand what that is, but it'll give you enough credibility to say, believe me, it knows who you are, that sort of thing. You know? Okay. Anything else? Ah, sorry.
Simple question, why Hollywood?
That was our internal project name. And no one could think of anything better. And it turned out it doesn't actually encroach on anyone's trademark. Because you can't trademark Hollywood, can you? Oh, one more question. Thank you.
Hi. Do you see any risks in giving this kind of auto ML or auto AI to users, bearing in mind that you have to have certain principles in mind to make sure that your model is robust, and perhaps, you know, those features that your model are identifying as the drivers, as you said in supervised, is not biased or is not, you know, somehow misleading the user?
No, it's a good question. It is the same question people were asking when these vendors were trying to push self-service BI. Isn't it better if I give our users a report so they don't make any mistakes rather than giving them the tool to do their own? I think it'll take training. And so this should be a company-wide effort. So there is a model that's going to give us better way to approve loans or whatever it is. But that's all now. Here's training to go through what are the implicit biases and so on and so forth, and use this application. If you get these sort of results, then you should question it in this way. It's not, this is why I think in 10, 20 years' time, the biggest demand for data science machine learning team will be philosophy majors, really. Because the math will not be a challenge. The computer science is not a challenge. It's really that, the ethics. Thank you. Great. Thank you so much for coming. Thank you.